Hello everyone, welcome to the class. My name is Pooja Dwivedi. Today we are going to discuss a very important topic that can be seen in your exam. One very important topic, however, very few children, very few aspirants have an actual understanding of how the interior of the earth works. Many of you must know about the crust, the mantle and the core understanding of the interior of the earth. However, have you ever understood about the mechanical divisions of the earth? Now, as we move ahead, I would like to tell you that UPSC has become a different ball game. And in order to ensure that you work along with the UPSC examination, we also need to understand that UPSC is going much more deeper by each and every passing year. So in order to make sure that no one fails or no one gets behind in this continuous upgradation, I am here with my topics, especially of geography, so that you can understand how to deal with the upcoming paper. Now, without any further delay, I would like to introduce you to today's topic. We are going to understand certain very important concepts, so make sure that you stay till the end. This is not going to be a very long topic. It will wrap around within 30 minutes. However, it is going to be of extreme help, not only in your UPSC examination, but any other state PCS examination as well. Okay, so let's begin. The interior of the earth, as you can see, the interior of the earth, I have already written certain topics. However, this map is going to make you understand how we are going to go through the entire class. So, the crust, the mantle, the core. We have already heard about these three areas. However, very few students know that there is also lithosphere, asthenosphere and the mesosphere. So we are going to talk about that as well. So let's start without any further delay. As you can see, I have already written how the interior of the earth is divided into. There are two divisions on the basis of elements and rocks, and the other one is on the basis of mechanical actions. So elements and rocks refer to the kind of elements generally found in the interior of the earth. We all know that the interior of the earth actually comprises of certain very basic elements such as nickel, we have iron, we have silica as well, okay, we have potassium, we have magnesium, even oxygen, alright, we have calcium. And how can we ever forget silica, aluminium? So on the basis of elements that are generally found within the interior of the earth, in addition to the types of rocks, for example, what kind of rocks exist in our interior? There are two basic types of rocks. First is felsic and another one is mafic. So felsic rocks and mafic rocks, what are these? I will get into it. However, just understand, on the basis of the elements and the rocks, we divide our interior into three different regions. First is the outermost layer of the earth's interior basically. This is the crust, alright. The second one is the mantle. And the third one is the core, of course, and the core is further divided into the outer core and the inner core. The outer core is liquid and the inner core is solid. This is on the basis of elements and rocks. Now, when we talk about the mechanical divisions of the surface of the interior of the earth, we talk about the mechanics and the physical makeup of those layers. How are they actually appearing to be? Are they solid? Are they semi-solid? Are they liquid? So on the basis of that, on the basis of physical appearance, we divide our interior into, our Earth's interior into three categories. First is, of course, the lithosphere. Second is the asthenosphere. And third is the mesosphere. Now mind you, you do subscribe to my Telegram channel, because all the notes that I am pointing out here, I'm using here and I'm making out here, it will be given through the Telegram channel. I also have the answer writing course. So if you're interested, you can get through me. I have the contact number given there as well. Alright. So on the basis of mechanical appearance, the Earth's interior is divided into lithosphere, asthenosphere and the mesosphere. Alright. So now let's get into it. How do we see the interior of the Earth? As we see this particular note, I have already given you the division on the basis of the elements and the rocks, right? And I told you that I will talk about rocks, felsic and mafic. Now, felsic rocks are those rocks which are composed of lighter elements. Lighter elements include, of course, silica, oxygen, alumina, magnesium to certain level, calcium. These are lighter elements. Felsic rocks are made up of lighter elements. Then there are mafic rocks. Mafic rocks are made up of heavier elements such as nickel, iron, etc. Alright, so this is the basic division between felsic rocks and the mafic rocks. Alright, so felsic and mafic rocks are found in the crust, they are found also in the mantle, and eventually certain material of them such as nickel and iron, they are found in the core as well. As we move forward, we will first talk about how the interior of the earth is divided on the basis of elements and rocks. Now, elements and rocks do include all these elements that we are going to talk about. If you look at these graphs, if you look at the pie chart, the entire earth's crust as well as the entire interior of the earth is divided in this manner. Now, if we talk about the entire interior of the earth, including the crust, the mantle and the core, the highest amount you will see will be of iron. That means throughout the interior of the earth, the most abundant element is iron, and we all know that iron is actually found in core, both in outer and inner. Next will be oxygen with, of course, as you can see, 29.5%. Then you have with 15.2% silicon. Eventually you have 12.7%, that is magnesium, and then the remaining ones, the nickel, sulfur, titanium, etc., etc. Now, if I just talk about the crust of the earth, the crust of the earth majorly comprises of oxygen. Please keep this in mind. This is very important. This can turn into a question as well. So very important, keep this in mind that the crust of the earth is actually comprising of oxygen in abundance. Then next element is silicon, the Sial and the Sima. We all know the story of Sial and Sima. I will of course tell you about it as we move forward. Now eventually we have the others as well, aluminium with 8.1%, then we have iron, calcium, sodium. This is just for crust, alright. So those of you who think that the entire iron, entire nickel is found only and only in core, no, it's not so. There are many elements which can be traversing across all the layers of the earth. So do not worry about that, alright. Now, this is related to crust only, and however, the next one which I made you see, the first one which I made you see, which is chemical composition in percentage, this is for the entire interior, the crust, the mantle and the core. So, if a question comes, which element is the most abundant in the interior of the earth? That means it is asking as a whole, for the whole of the earth, whole of the interior of the earth, then you will answer it as iron. But if it is asking only about the crust, then you will answer oxygen. Please, because these are the things, these are the keywords aspirants do miss when they are going to read the questions. So don't worry about that. Just be very calm whenever you are reading your question paper. You have to be calm, you have to be composed, you have to tell yourself it's okay, I will do this paper, I will definitely get into the list. बहुत ज़्यादा टेंशन लेने की ज़रूरत नहीं है, ठीक है, पेपर ही है, निकल जाएगा, कौन सी बड़ी बात है। बड़ी बात अभी लग रही है, जब पेपर दोगे तब पता चलेगा, उसके बाद जब मेरी पोजीशन पे आ जाओगे फिर लगेगा कि अरे मैं तो इतना ही परेशान होता था, ज़बरदस्ती होती थी, है ना। चलो, लेट्स टॉक अबाउट द फर्स्ट layer on the basis of elements and rocks. Now, on the basis of elements and rocks, we have the crust. If we just reach the radius of the earth, one can actually just have some आकलन or approximation about the radius. According to NCERT, we have 6,371 kilometers. It is given in the NCERT. I always tell my students, please, please, please read the NCERTs. NCERTs are a must whenever you are giving any exam, especially the UPSC examination. Don't worry about the wobble of my camera. I'm just starting, yeah, you know, so I have a little wobbly table. So just don't worry about that. Okay, so whenever I teach, I tell my students that please do concentrate on NCERT data, because NCERT is something that will always be cited whenever any dispute occurs. So NCERT has specifically said, guys, that 6,371 kilometer is the radius. Okay, so we will stick to that. Now, as we have come across this radius, now we will understand to which depth different layers of the earth are penetrating. First is the crust. Crust actually is the outermost layer of the earth. So keep this in mind. This is the outermost layer of the interior of the earth. All right, of the interior of the earth first. Now, in terms of volume, that means the space that it covers of the entire interior of the earth, it is just 0.5 to 1%. That's it in terms of volume, in terms of the space that is occupied. And if we talk about the mass is less than 1%. Now, this means, however, we walk on the crust, we build our infrastructures on the crust, it does not occupy a very large space. Also, the crust, what we see, is actually divided into two areas. First is the continental crust. Continental crust is the crust which makes up the continent. For example, this is the continent. You have your mountains. For example, these are the Himalayas. You have your plateaus, you have every other relief feature. Now, another one is the oceanic crust, on which the ocean lies. Okay, so we have the continental crust and we have the oceanic crust. Both are made up of similar and different materials. For example, if we talk about continental crust is majorly made up of silica and aluminium, and that is why it is known as Sial. So this region of the continental crust is known as Sial. However, oceanic crust is made up of silica and magnesium. That is why it is known as Sima. It's not the Sima Chachi, but Sima. Okay. Now, the continental crust and the oceanic crust are also made up of different rocks. For example, if we talk about continental crust, it is made up of granite and specially felsic rocks. I have already told you what felsic rocks are. And if we talk about continental crust, it is made up of basaltic rocks. Okay, basaltic rocks and majorly mafic rocks. So that is why there is a difference in the rock system as well. Now, if we talk about the depth, the general depth that we consider is between 0 to 100 kilometers, and it differs. In continental crustal areas, it is much more deeper. The depth of the crust is much more. For example, near the Himalayas, it could range between 35 kilometers to 70 kilometers. However, when we talk about Sima, I mean the oceanic crust, it is less deep. It is just 5 kilometers approximately. 5 kilometers. So that is why we can say that between 0 to 100 kilometers, the depth of the crust is presiding. Now, as we have concluded with the first layer, we move on to the second layer. The second layer is the layer of mantle. Mantle is a very interesting place. Why? Because mantle itself is divided into two layers. First one is the upper mantle and second one is the lower mantle. And the mantle is found within 100 kilometers from 100 kilometers to 2900 kilometers. This is the range of the mantle. Now the mantle, as I said, is divided into two parts, the upper and the lower mantle. In that also we have certain divisions. For example, the upper mantle is divided into two more parts. This one, which I have drawn in green, this one is actually the solid but at the same time brittle mantle. And the next part, the one which I am going to draw now, of course, why wouldn't I draw it in orange? Because we are talking about the asthenosphere. This layer of the mantle, it is a part of the upper mantle only. However, this interestingly is a very weak layer, the asthenosphere. Asthenosphere actually comes from a Greek word, astheno. Astheno means weak. That means it is molten. It is viscous. And it could be found up to, from the surface of the earth, up to 400 kilometers. Like between 200 to 400 kilometers, it is generally found. Alright, we can say 200 to 400 kilometers. Now, asthenosphere is of specific concern because this layer, which is a part of the upper mantle, it is made up of molten magma and lava. This layer helps us in understanding how the interior of the earth is made, because the seismic waves which are generated by seismic activities, earthquakes, it acts very differently over this region. That is why asthenosphere is going to be of special prominence when we are going to talk about the tectonic activities of the earth. Alright. Now, this is a layer where convective currents rise. Alright. So, let's write down certain points about the first portion. Now, mantle is further divided into two parts, upper mantle and lower mantle. Upper mantle is further divided into two parts, and the two parts are solid brittle part, which later on will be very important for us to understand when we are going to talk about the mechanical divisions. Solid brittle part. And the next one is the asthenosphere, which is the molten, viscous, it is the source of lava as well, viscous fluid portion. It extends up to, as I have told you, 2900 kilometers. Now, the next portion, the lower mantle. Lower mantle is solid, and this is the entire lower mantle is comprising of what we call as the mesosphere. Mesosphere is present in your atmosphere as well, which is also called the Madhyamandal. Madhyamandal means being in the middle. So here mesosphere is proving to be the same for the interior of the earth, the Madhyamandal. Alright, so we have these two, the upper mantle, the lower mantle, solid, mesosphere. This is generally made up of actually metamorphic rocks. Metamorphic rocks. Now, as you can see, this region is too huge, right? You have so much going on in the mantle. So we can say that approximately in the mantle, 84% of Earth's volume is occupied by mantle, and approximately 67% of Earth's mass. Now we move on to core. The story of mantle is over for now. We move on to core. Now the core is further divided into two portions. One is the outer core and another one is the inner core. Yes, right, three ends. The outer core is found between 2900 kilometers up to 5100 kilometers. This outer core and inner core both are made up of two very important elements, nickel and ferrum. That is why they are known as knife layer. Just one difference is there, that outer core is liquid and it rotates along with the rotation of the earth. This is the layer that is going to make the magnetic field of the earth, because this comprise of magnetic materials. The inner core, however, is solid in nature. जैसे बहुत ज़्यादा प्रेशर पड़ रहा है, टू मच प्रेशर. In fact, once you reach the inner core, as we go from the first layer to another, it is approximately by every 30 kilometers, by every certainly 1 to 2 kilometers, you will find a 30 degrees Celsius difference. So by reaching up to here, you can find a temperature of 6,000 degrees Celsius. Now this gives us the idea that it is so hot in the innermost layer of the earth. Still it is solid. What is the reason behind it? The reason is simple, it is pressure. Too much pressure has been provided to inner core, and that is why it had to solidify. This is the only reason. So this is the Nephi layer, very important for us. Two layers, the outer liquid core and the inner solid core. And the outer liquid core actually rotates and makes the magnetic field, right? To the inner solid core, we reach a capacity of 6,000 degrees Celsius. My God, let's move on. This is almost as warm as the sun. Now, as we have all now completed the divisions on the basis of elements and rocks, these are not just the sedimentary rocks, the metamorphic rocks. We talked about the mafic and the felsic rocks as well. Beg your pardon. Now, move on to the mechanical portion, the mechanical divisions. As I have told you, the mechanical divisions refer to how the physical structure of the interior appears. Now, on the basis of that, we have three layers: lithosphere, asthenosphere and mesosphere. You have already understood about asthenosphere and mesosphere. However, we have to talk about lithosphere a bit. I will talk about the other two as well. Now, as you imagine, as you remember, don't imagine, guys, too much pressure on the brain. Now, the crust is completely solid in nature. It comprises of the continental crust and the oceanic crust. Good. But mantle also, up to the upper part of the mantle, up to a certain limit, it is also solid. So this is the solid brittle mantle. Now, imagine these two coming together to form a group. The entire crust plus the upper solid brittle part of the mantle. Now, these two, when they join hands together, saying that we two are very strong, we become the lithosphere. So this is what the concept of lithosphere is. Mechanically, this is a very solid layer. So it's made up of crust and upper mantle. This is the layer, this is exactly this lithosphere will be further talked about in plate tectonics as well. We all imagine that the lithosphere is a continuous layer. It does not have any breaks or it doesn't have any cracks. However, this is not true. It does have breaks, it does have cracks. That is why it floats on the next layer, which is the asthenosphere. We will talk about that as well. Now, given that crust is approximately 100 kilometers, the next 100 kilometers belong to the upper brittle mantle. So that is why a lithospheric plate is generally 0 to 200 kilometers deep. And all natural earthquakes come here only. All natural earthquakes. The lithosphere is not a continuous layer. Keep this in mind. ये continuous layer नहीं है. Okay, and it floats on the asthenosphere, making tectonic activity possible. Okay, keep this in mind. Also, it is divided into different plates. This will be the theory of plate tectonics. Into different plates. Got it? This is not the plate that we keep in hand and stand in front of the chart wala, not that one. Don't get hungry. Next is, of course, the asthenosphere, which I have already told you that after 200 kilometers it begins. All natural earthquakes exist in this region only and only because the asthenosphere starts beyond this. Alright. So asthenosphere is as the Greek word suggests, astheno means weak. It's the weak layer. It is the same layer in which convective currents arise. Convective currents we will discuss it when we discuss the theory of convection, the theory of convection currents, which was suggested by none other than Arthur Holmes, who tried to overcome the pitfalls and the dooms of what we know as the continental drift theory. तो उसमें ध्यान रखिएगा. But this is the layer of convective currents, and it belongs to, of course, the upper mantle. It is approximately between 200 kilometers to 400 kilometers. Okay, so this was suggested by Arthur Holmes in the year 1930. Got it? Next is mesosphere, which is the next layer. Now, after these mechanics, other mechanics have already been told to you, the liquid outer core and the solid inner core. The mesosphere is actually completely lower mantle and it is solid. It's not very interesting for us to know over here. The entire lower mantle is comprised of mesosphere. This is solid, specially made up of, this will be found between 400 kilometer approximately to 2900 kilometer. Solid, made up of Rupantarit Chattan, which we know as metamorphic rocks. Okay, because they have changed and then deposited themselves. Now, how about seismic discontinuities? What are seismic discontinuities? What is the purpose of seismic discontinuities? Basically, whenever the earthquake creates seismic waves, they travel differently. We all know that there are two major kind of waves. One are the body waves and other ones are surface waves. So body waves, they travel throughout the interior of the earth. That is why they are known as body waves. So throughout, I said 30 minutes, just 5 minutes इधर उधर होगा भैया, ज़्यादा परेशान मत होना कि अरे आप तो 30 minutes बोले थे but अभी तो 35 minutes हो रहा है. Throughout the interior of the earth. Relax everyone, सब कुछ होगा. So body waves, as they travel throughout the interior of the earth, there are certain regions where the velocity of the waves get impacted. Velocity of the waves get impacted. Because of this, we understand that the interior is not uniform. It is made differently. Because waves behave differently in each layer, and wherever they start to get their velocity intervened, जहाँ पे velocity थोड़ा सा change होने लगता है, there we will find the seismic discontinuities. Now, if we talk about seismic discontinuities, there are majorly 5 seismic discontinuities. Okay. First is, of course, between the crust and the mantle, we have the Mohorovičić discontinuity. Keep this in mind. This is between whom? Crust and the mantle. Then between the mantle and the core, we have the Gutenberg discontinuity. Then finally, we have other discontinuities which exist within the same layer as well. For example, between upper crust and lower crust, we have Conrad discontinuity. Then between upper mantle and lower mantle, we have the Repetti discontinuity. And finally, between the outer core and the inner core, we have the Lehman discontinuity. So in this manner, we have 5 discontinuities. I have already told you, and I have told you what to look out for. We have to look out for that the velocity of the waves get impacted, and hence we will find the discontinuity. So they help us in understanding the interior of the earth, the discontinuities. All right, that is why they are important for us to know. Now, I have completed a very important topic, and now what will happen, that as I have completed this very important topic, you will do just one thing. You will continuously ensure that you remain, attentive of my schedule, so that nothing gets missed out. टेलीग्राम चैनल प्लीज़ एंश्योर कि उसे आप सब्सक्राइब कर लें जितना जल्दी हो सके, ताकि सारे नोट्स मिले. आंसर राइटिंग प्रोग्राम हैज़ ऑल्सो स्टार्टेड, सो यू कैन सब्सक्राइब देयर एज वेल. थैंक यू सो मच एवरीवन. स्टे अपडेटेड एंड टेक केयर.